The topic is reversing the order of integration for double integrals. So let's do this example. Reverse the order of integration for the double integral. The x goes, let me do this. Since this is dx, the x goes from -2, let me rewrite it. X goes from -2 to 3. And then y goes from, the inner integral is y because it's with respect to y, from x squared minus 4 to x plus 2. Right, so dy dx. In other words, now, so we have a type 1, and we need to rewrite it in type 2 to have a dx dy. So first, let's sketch the region. X goes from -2 is -2 to 3. Y goes from x squared minus 4. Remember, x squared minus 4, let me just draw small. X squared minus 4 will be x squared shifted 4 units. So it should look more like this, right? This is y equal x squared minus 4. However, we know that this is going to be, if you set x squared minus 4 to 0, you get -2 and 2, which is x-intercept, right? So we know that we go, when x is equal -2, I'm talking about this one, when y equal x squared minus 4, when x equal -2, y equals 0. So that's this point. When x, y-intercept, when x is 0, y is equal -4. That's another point. And then we're interested in x-intercept. When x is 2, y equals 0. So here's another one, just to be good. And then when x is equal 3, because we're interested in that, limit of integration, if you plug a 3 here, you get 9, 3 squared, which is 9 minus 4, which is 5. So 3 is a 5. 3, 5 will be here. So the parabola is going to look more like that. Alright. Now what about graphing y equal x plus 2? Y equal x plus 2. So this is y equal x squared minus 4. Y equal x plus 2 is easy, it's just a line. So all I'm interested in, when x equal -2, x equal -2 means y equal -2 plus 2, which is 0. This is my first point. Let's just do y-intercept. Y-intercept means when x is equal 0, plug the 0 here, y equal 2. This is another point. Then I'm interested at x equal 3. When x equal 3, y equal 3 plus 2, which is 5. So I got this. So here is my region. Alright, now we need to go backwards. We need to reverse the order of integration. However, we have one problem. When we go from left to right, see, when we go from left to right, it depends where we're going. So if we're going from here, this is not, or if we're using, we're going from left to right on this region, this is a different function. So what we do, we're going to call the bottom one R1, we're going to call the top one R2. Now we want to go from y, from here to here. So from y equal, this is -4, from y equal -4 to 0, right? That would be region R1. And then we're going to go from 0 to 5. Y goes from 0 to 5, and then we'll get something else. So let's do it. So for the region R1, y goes from -4 to 0. For R2, y goes from 0 to 5. Right? Now what else? What about the x? The x goes from what? Now this is this is y equal x squared minus 4. If I solve for x, I get x squared is equal y plus 4. x is equal minus square root of y plus 4, or x equals square root of y plus 4. The left one is x equal minus square root of y plus 4, and then the right part of the parabola will be x equals square root of y plus 4. Why? Because x here is positive and x here is negative. So we need the left one. So this is x equal minus square root of y plus 4. So for region R1, we're going from this graph to this graph. In other words, and this is just x equals square root of y plus 4. So we're going from minus square root of y plus 4 to square root of y plus 4. Now for the region R2, we're going from here to here. Now this is still x equals square root of y plus 4, but the left side we need to find the equation. Well, we know the equation of this line. This is y equal x plus 2. So if we solve for x, we'll get x equal y minus 2. So my x goes from y minus 2 to the part of the parabola square root of y plus 4. Now let's write the example. Let's call this example 1. So 1 will be equal the sum of two double integrals. First double integral over R1, the y goes from negative 4 to 0, the x goes from negative square root of y plus 4 to square root of y plus 4, and it's f of xy, and this is now dx dy, not dy dx, so dx dy, plus, and then over the region R2, the y goes from 0 to 5, and the x goes from y negative 2 to square root of y plus 4, and it's f of xy dx dy. And that's it for this example.